Hello students. So today's lesson is on a number sequence. Now what exactly a number sequence? Basically it is to recognize that numbers when they progress in certain manner there's actually a pattern, which is why sometimes this chapter is also known as number patterns, right? So as you can see we actually want to pattern model and the regularity in the world to see some kind of structure. Now, sequence are actually functions where each term in the sequence is uniquely determined by its term position. So we will see how it works later, right? So it works as a function. We have actually recently just learned algebraic function, which is why this topic is suitable to come immediately after that, right? So let's jump straight in. So to get started, here's some of the things you should know, right? So for example, we have a stadium, right? And a stadium, we have chairs. As we know, the chairs are around the perimeter of the stadium. The further away you are from the center, they are actually, the perimeter actually get larger, right? So you can actually fit more seats. So suppose there's a particular stadium, it works this way, right? So for every row, okay, the first row, there's actually 20 seats, right, for a certain section of the stadium. Second row, 24. Third row, well, we expect it to actually increase in the number of seats. So, do we see a pattern here? Well, if we just were to follow the pattern and we assume that the pattern follows, then what happened is from 20 to 24 is actually an addition of 4. So if this pattern will persist, then the next one here will be 28, right? And the next one here, plus 4 again, will be 32. So this is fine if we are just finding the first 4 rows. But the questions become challenging if we ask for the 10th row, right? Now, the 10th row, we can still actually count. It's not impossible, but it gets tedious, okay? Moreover, it gets even worse if we go on and ask for the 34th row, right? So it's going to be a lot of counting. So we want to find some kind of ways to actually generalize the pattern so that we can actually answer questions. So in the R row, no matter what is the row number, as long as I know the value of R, I should be able to actually find the seats, right? The number of seats. Alternatively, right, we could also ask questions like in which row there are 416 seats, for example. So we got to actually work backwards. So of course we'll go into detail, but for now how this works will be this, right? So first row there's 20, okay? So I will keep adding 4. So 10 row I actually add 4 a total of 9 times. So actually it's going to be 4 times 9 over here, which will result in 56 seats, okay? We will see a proper generalization later, right? So for the second one, if it's 34, again, I start from 20, and then I actually add 4, 30, how many times? 32 times, right? Sorry, 33 times. So be 4 times 33. Okay, I'm going to need a calculator for this. Give me a moment while I dig out my calculator. Calculator, 4 times 33 plus 20, 152 seats. Right? There we go. Okay. Is there other clause? No. Right? So what happened in the R row? R row, what happened? So what we notice is that, okay, very quickly, let me highlight this. Down here, I multiply by 9. Down here, I multiply by 33. You notice that 9 is actually 1 less than 10. Over here, 33 is 1 less than 34. So if you're observant enough, you will know that to get the number of seats, I will take 20 plus 4 times R minus 1. Okay, so this is actually how we can actually calculate. And finally, what happened is if, right, okay, 20 plus 4 R minus 1 is equals to 416. Then 4 R minus 1 is equals to, this will be 416 with my calculator again. 416 minus 20, which gives us 396 divided by 4. right? R minus 1 equals to 99. That means my R is equals to 100. So we are looking at the 100 row, which will have 416 seats. So here's just a very simple example to get us started. This is what we're going to be dealing with for the rest of this very short chapter. So let's move on. Okay. So let's figure out the first thing, right? The example that you have just seen is what we call linear sequence. Why is it called linear sequence? Because the difference from one term to the next term as we progress, they actually grow linearly. There are other patterns, right? Non-linear sequence, as you can see in the pink box. Those requires other techniques which we will deal with in a later date. So for now, we'll just deal with the green boxes. Those are linear. Okay. What you notice is that they actually have this thing called the common difference. So you can see here, common difference. That's the thing I want to highlight for you, right? So if they have a common difference, they are called linear sequences. Okay. So here are some linear sequences. The first thing that we want to do is we want to identify the common difference. Are you able to identify the common difference? Well, the first one is done for you. So 8 to 16, you actually plus 8. 16 to 24, you plus 8. 24 to 32, you plus 8. So we add 8 every step of the way, right? Now, for the second pattern, right, second sequence, from negative 3 to negative 10, we actually subtract 7. Then negative 10 to negative 17, subtract 7. So down here, this one is actually negative 7. I just remove this, right? How about the next one? 7 to 2.5. Can the difference be decimal? Of course it can, right? So 7 to 2.5, we actually subtract by 4.5. And when we take 2.5 subtract by 4.5, we do get negative 2. So it is a linear sequence. So we do this, right? And how about the next one? Can it be in terms of algebraic style? Yes, A, then A plus 3, then A plus 6. Basically, from one term to another term, we add 3. So over here, the common difference is 3. So far, so good, I hope. Right? So that's the first thing we do. When we want to figure out a linear sequence, the first thing that we try to identify is the common difference. Let's move on then. Okay. So some of the words that I've been using, sequence, okay, know their meaning. A sequence here simply means a ordered list of numbers, right? And if the difference is consistent, we call it a linear sequence. Now, I also use the word term, right? So each of these numbers in the sequence, they are called a term. And the term is identified by a position. So T1, right? You can see T1 is called the first term. T2 is called the second term, right? T3 is called the third term, and so on and so forth. And then if you can express it in term nth, that means it's the nth term, that will be the general term, right? So usually we denote it, the terms are denoted in this manner. Take note, all right? Okay. And of course, we explain linear sequence already when there's a common difference. So all these are words, the meaning, I hope you get them because we'll be using them quite a bit in this chapter. So let's go on. So now, general term for the linear sequence is in this form, right? It will be good to actually remember it. It's quite useful. So if we are trying to find the nth term, what we are doing is we will take the first term plus, okay, one number less than the term position times the common difference. So we have seen this in the earlier example with the stadium seats. As you can see, here we go, right? The first term is 20. Right, because that's where n is equals to 1, where the row number is 1. So that gives us 20. So I take 20 plus, then 4 is the common difference. So 4 multiplied by 1 less than the term number. So the first one, 10 row, the term number is actually 10. Second one, the row is 34th row, so the n number is 34. So 1 less than that, 33. Okay, so you can see it at work. So very useful formula for all the sequences that we want that is linear. Okay, so looking back at this again, so how it works. So here's the example we were looking at earlier, right? The first term in this case is 20, right? Right here, right? It's here. 20, you can see that. And then the common difference is 4, right? So since this is a formula, you get 20 plus, then you have n minus 1 times 4, right? So that's exactly what we're doing. Of course, you can write 4 times n minus 1 or n minus 1 times 4. You know that you do get the same result, so it's quite fine, right? So this is the nth term. Okay, so let's look at some examples. So let's practice with this sequence. Okay, so here we go. We have this pattern here. From 22, it starts to reduce until 13. So the first term in this case is 22, right? And then the difference is actually negative 3. You can see it is subtract by 3, right? It repeats. So it works. So the common difference is negative 3. Therefore, the general term here will be 22 plus n minus 1 times negative 3, right? Of course, we can simplify this, right? This will be 22 minus 3n plus 3, which result in 25 minus 3n. So we can simplify it once we have the values, right? So let's look at the next example. Now we have the sequence 3, 8, 13, 18. They want us to write down the next two terms. So let's identify the common difference. From 3 to 8 we plus 5, from 8 to 13 plus 5, 13 to 18 plus 5. Therefore, the common difference is 5. So 18 plus 5 give us 23. And then 23 plus 5. 23 plus 5 gives us 28. Right? Okay. So once we have that, let's find the general term using the formula again. In this case, it is first term is 3 plus n minus 1. Sure, let's write it down. N minus 1. The difference is 5. Okay, so we simplify this. This becomes 3 plus 5n minus 5, which result in 5n minus 2. There we go. So usually after we find the general term, you know, the question could also have one final part where you want to find a term that's quite large. In this case, the 50th term, right? So all we need to do to recognize that is now n is 50. Therefore, the way we can actually present our answers, we're going to write down T50, right? This is one way we can say T50 here means 50th term. And it will be equals to 5 and times 50 minus 2. Okay, and that will bring us to 248. Okay, so yeah, try not to mix them up. Okay, so yeah, another question successfully completed. I hope you get it so far. Right now, feel free to pause the video if you want to try the questions on your own before you check whether your answer actually match with mine. That will be a much better way, more effective way of learning rather than just listening to my explanation all the time. But of course, you can listen to all my explanation first. Then after that, pause the video, go back and try again. Then watch the video another time to confirm that you have actually gotten the questions correct. Right? Okay, the third question. Now, again, this time round, they give us the sequence. They tell us that the nth term is 2n minus 3. So this time round, we don't need to find the general term. It has been found for us. Instead, they want us straight away to find the third term. So how do we present it? Third term, we put down T3, right? So T3 means 2 times 3 minus 3. In this case, that will be 3, right? And then they ask us to find the difference between the third term and the fifth term. So we got to find the fifth term, right? Fifth term is T5, which is 2 times 5 minus 3, which is equals to 7. Therefore, the difference is equals to 7 minus 3 equals to 4. And then they could also ask for the product. So all these words, we need to know the meaning. The product of the 6th and the 10th term goes like this. The 6th term was T6, which will be 2 times 6 minus 3, which is equals to 9. And then the 10th term is T10, is 2 times 10 minus 3, which gives us 17. Therefore, the product is equals to 9 times 17, which will be 153. There we go. Okay, I hope you're following so far. All good? Right, let's move on to the next section. So now the next section, what happened? We are going to look at some word problems, right? Word problems, they appear. So you can see straight away we have one quite interesting question because it deals with chemistry, right? So for those who study chemistry, you'll be familiar with this. These are your chemical bonds. So these chemical bonds also follow certain pattern, right? So sometimes the pattern could be actually visual. So they want us to draw the next two figures. Sure, we can do that, right? So it will be C, 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 C this way, and then the hydrogens H, 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 H. Looks good. And two more here. Cool, right? So from one figure to the next figure, basically we increase the number of C's on the left side. Just follow the same structure, okay? You'll be fine. So figure 5, well, one more. So this time around, let's count the number of C's. Make sure I get it correct. 1, 2, 3, 4, 5. Then this one, okay? H here, this way. Then sure, right? H, 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 H. Okay, so this is the easy part. It's all about recognizing the structure, right? There is no complicated cognitive demand here. Okay, so recognize the structure and then just follow suit. So draw the figure, right? So if you know your sizes, this is actually okay your pentane, and this is your hexane, right? Right, continuing. So now what happened, right? So in the next section, now we actually start to see the pattern, right? We have the figure number. So figure 1, 2, 3, 4, 5. They count the number of carbon, count the number of hydrogen, and list them down. So we have it in a little table here. And we are supposed to try to fill out the table, right? So replace the word A and S with the actual number. So this one is 5 and 6. So straight away I can see, right, that my carbon, the number of C, is actually one more than the figure number, right? Now my hydrogen increases by 2 each time, right? So it's 4 to 6 to 8 to 10 to 12, okay, right? So down here, this one is actually C3H6. Oops, did I write it wrongly? Yeah, I wrote it wrongly. Let's go back. It's C4H8, C5. Let me try again. C5H10, C6H12, right? That's what we get. Okay, so we do see a pattern straight away, okay, even in nature, right, like carbon, all the chemicals and so on, okay. So based on this, they want us to generalize the pattern observed and write down the formula for alkane, okay. So alkane is C, right, CN, H, 2N, right? It's just two more, okay? So if a member of the alkyne family has 15 carbon, how many hydrogen will it have? So from here, we know that the number of hydrogen is 2 times more. Therefore, the answer is 30, okay? And if a member of the alkyne has 42 hydrogen, how many carbons, right? So it's half of it, 21. Okay? Right, let's move on. Okay, the rest of the section here are actually further exploration, showing you some famous sequences. They are technically not in your syllabus, but then of course if you are interested and you find this number sequence interesting, they are very useful for a lot of situations. Feel free to read out on them. The hyperlinks are there. I will actually provide the soft copy of this handout to you, right? So you can just click on the hyperlink and check it out. So first one, there are actually such thing called happy and sad numbers, right? So in case you are unaware, very interesting names for them. So read them out on your own. I'm not going to go into details here because it's unnecessary and you'll make this video too long, right? Quadratic is another one. Now quadratic will do appear in your syllabus, but not currently, because you are currently Sec 1s, you will see them again when at a higher level, right? So quadratic, what happened is the difference, there are actually two layers of difference, as you can see. And then instead of having a linear equation, it's a quadratic equation, right? So you will see them in the future, right? Pascal triangles, very popular, right? As well as some of the other harder to pronounce sequences. So just for your interest, okay? Extension. So the thing about the common difference, they do have a official name. They are actually called arithmetic progression. Now, progression, what happened is there's actually a proper formula for that. When we keep adding a common difference, we have already dealt with that, right? So if sometimes we need to check, okay, so if the sequence do not have a common difference, then there is not considered arithmetic progression. So just like answering the questions here, okay. So how about this sequence? Again, there's no common difference, right? The common you cannot add 2 in one step and the next step you subtract 2 and then add 2 again. It doesn't work. It's still not the AP, okay. So AP, we have dealt with it. This is what we have done. AP is what we have been doing so far. So other than AP, the other very, very popular one is actually your GP, right? The difference between AP and GP is AP has a common difference. GP actually have the common ratio. So common ratio means I keep multiplying by the same number instead of adding by the same number, okay? So all this you can is provided in your notes. Feel free to read them. Like I say, these are extensions, so I do not want to actually put them go into details in this video. You do not need them yet for the purpose of what you need to know at Sec 1 level. But of course, if you're interested, feel free to read them in detail, right? So I'll just show them here. And that's the end of this particular lesson. I hope you have learned something. Now, I believe if you are my actual students and not just someone who stumbled on this YouTube video, you will have a handout from me. Complete the handout, the worksheet, and we'll discuss the worksheet when we see each other again in the classroom. All right? Have a nice day.